Welcome. In this session, we are going to continue looking at examples where we combine the chain rule with the product and the quotient rules. I mentioned a couple of times that once we have the chain rule, we can combine that with the product rule in place of using the quotient rule. Let me illustrate that with this example. I'm going to differentiate the fraction 1 plus v cubed to the power 2 over square root of 1 plus v power 4 to the power 3. We'll use negative exponents to write this as a product. So I should take the numerator multiplied by reciprocal of the denominator. Let's first write the denominator as a single power rather than square root of a power. Square root is same as power 1/2, which means that the denominator is 1 plus v power 4 to the power 3/2. If I bring it to the numerator to take the reciprocal, in other words, I should change the sign of the exponent, which gives me 1 plus v power 4 to the power negative 3/2. Now I just use the product rule. So let's start by differentiating the first factor. The first factor here is 1 plus v cubed to the power 2. Since it's power of a function, I have to use the power rule and chain rule. First I differentiate for the exponent 2, which gives me 2 times 1 plus v cubed to the power 1. I should multiply it by the derivative of the inside. The inside is 1 plus v cubed. Its derivative is 0 plus 3v squared. Times the second factor, 1 plus v power 4 to the power negative 3/2, plus the first factor, 1 plus v cubed to the power 2. Now I need to differentiate 1 plus v power 4 to the power negative 3/2. So again, I'm just going to use the power rule. I differentiate for the exponent negative 3/2 first. So I get negative 3/2 times what's inside the parenthesis to the power negative 3/2 minus 1. Negative 3/2 minus 1 is negative 5/2. Now I should multiply this by the derivative of the inside. The inside is 1 plus v power 4. Its derivative is 0 plus 4v cubed. Again, if I don't want to simplify, I am done. Of course, sometimes we need to simplify, and in problems like this, simplification involves a bit of algebra that you may not have done very much of in high school. So let me just show you one or two of the tricks of the trade in simplification. We will find the derivative of 1 plus x cubed over the quantity square root of 1 plus x squared to the power 3, but we are going to simplify the answer as much as possible. This time I'm just going to use the quotient rule rather than the product rule, but I will still write the denominator as a single power. So square root of power 3 is same as power 3/2. So I'm going to use the quotient rule. Quotient rule tells me that I first differentiate the numerator. The numerator here is 1 plus x cubed, its derivative is 3x squared. Multiply by the denominator 1 plus x squared to the power 3/2 minus the numerator 1 plus x cubed times derivative of 1 plus x squared to the power 3/2, denominator of the function I'm differentiating. It's power of another function, so I use the power rule multiplied by the derivative of the inside. So for power 3/2, derivative is 3/2 and then power 3/2 minus 1. 3/2 minus 1 is 1/2. I must multiply it by the derivative of the inside. The inside is 1 plus x squared. Its derivative is 2x. The whole thing over square of the denominator of the function I'm differentiating. Now I need to simplify this. Since this is a fraction, to simplify it, I factor the numerator. The denominator is already in factored form, and then see if I can reduce. If we have a fraction where in the denominator you have an exponent other than 1, something bigger than 1, you will always be able to reduce the fraction. You will be able to factor a power of the expression inside the parenthesis from what the quotient rule gives you. Before I do that, let's simplify this a little bit. I can multiply 3 halves and 2, that's just 3. Now let's look at the two terms in the numerator and see what we can factor. Both terms have 3 as a factor, so I can pull that out. First term I have an x squared, in the second term I have an x, so I can pull out an x. In the first term I have 1 plus x squared to the power 3 halves. Second term I have 1 plus x squared to the power 1 half, so I can pull out 1 plus x squared to the 1 half. I'm going to leave the denominator in the form power 6 halves. You will see in a minute why. So I'm factoring out a 3. I'm factoring out an x. I'm also factoring out 1 plus x squared to the power 1 half, because these are the factors common to both terms in the numerator. In the first term I pulled out a 3. I had x squared. I pulled out an x. That leaves an x inside. I had 1 plus x squared to the power 3 halves. I am pulling out 1 plus x squared to the power 1 half. So that leaves 1 plus x squared to the power 3 halves minus 1 half, or 2 halves. If I look at the second term, 1 plus x cubed stays inside. I pulled out the 3. I pulled out the 1 plus x squared to the 1 half. I pulled out the x. So only thing left is 1 plus x cubed. But remember, this minus applies to all of this, so I'm going to keep the parenthesis in and then distribute it in the next term. Now I can reduce this fraction. I can divide both the numerator and denominator by x squared, 1 plus x squared to the power 1 half. So this cancels, and the denominator will have 1 plus x squared to the power 6 halves minus 1 half, or 5 halves. And I'll have the 3x outside. Inside the braces, I'm going to have x times 1 plus x squared, or x plus x cubed. Denominator, as I already said, I have 1 plus x squared to the power 5 halves. Then distribute this minus, which gives me negative 1 minus x cubed. Now I can combine the like terms inside the braces. X cubed minus x cubed is 0. So altogether the numerator is just 3x times x minus 1. The denominator, if you use radicals, can be written as square root of 1 plus x squared to the power 5 halves. This concludes our look at the use of chain rule in combination with other rules.